Thank you. So let's start. First of all, a quick introduction about myself. I work for a company called Opposing Force. We are an Italian security company. We do offensive physical security, SCADA stuff, and ICS research. And since last year, we are also member of securing smartcities.org, an initiative that is in place to help smart cities to get more secure. We did a roundtable yesterday. I don't know if you were present. You can find it on the YouTube channel of the Hack in the Box. So yeah, that's it. So what we are going to speak about today. So I will give a quick introduction about the engagement I will tell you about. And then I will briefly explain what I mean with this red teaming activity. And then I will tell you about how and what we did on the field, and why there is SCADA involved in this, and how we hack the SCADA device in order to gain our final goal. And then you can ask questions. So let's start with the introduction. So first of all, we got hired for a red teaming mission from an industrial manufacturer in Italy. I'm saying red teaming because it's not a real red teaming engagement, since there is no blue team on the other side. So we were actually alone. And before starting, I have to make another note. So some of the technical details that I will not speak about today now is because we are still under NDA from the company that engages us. So if you have any question about how we do something that is not explained here, you can ask me later, maybe at the lounge in the hotel, pay me a drink, and I will be more happy to answer that. Okay, so briefly, the engagement details for this work were, we were not provide any of the any addresses for the target, the facility target, and we had 7 days to complete the engagement. We only get the company names that hire us, and we had full control of the scenarios that we wanted to implement in order to succeed in the attack. So we also had 3 rules. The first one was that we were allowed to use any physical or cyber or human assets. We can attack any of those assets. So we could do social engineering, we could do attacking from cyber perspective, from remotely or on-site, the on-site network, or we can do a physical intrusion. We were not allowed to do any disruptive attacks, so we could not break windows, we could not cut through perimeter and stuff like this. And of course, no harm was intended against the personnel of the company. And there were only one simple goal. So this manufacturer produced a machine. This machine used a PLC in order to control it. And inside this PLC, there is a receipt, a software made by the company. And this is actually the intellectual property of the company that they want us to steal. So the goal was actually very simple. Just steal this receipt, this software, nothing else. So what I meant with the reteaming? So it's a simulation of advanced attack scenarios, usually driven by a goal or multiple goals. It's not limited to only cyber domain. It can also use, as we saw, physical domain, human domain, and as I said, could combine any of those. Usually is designed to test the maturity of a blue team. In this case, as I already said, there were no blue team in the company, but this is why it's not a real red team engagement. And usually we use this type of engagement to convince the management that the security is not good enough, and so they have to do more testing, more preparation for the security issue that they can encounter in the future. I will drink a lot, sorry. So we saw that we could use cyber attack, we could use physical attack, we could use human attacks. What we did is opting for a physical intrusion approach. So let's see what we have. So this is the standard flow that you usually follow, that anyone in the field usually follows to create a doable scenario for this attack. So we start with a OSINT, open source intelligence. Then we move on-site surveillance, so we take care understanding what is the physical security situation of the company, and then we define multiple attack scenarios, and we try to understand which is the best one to follow through. And after that, we prepare for the intrusion. In our case, as we will see later, we had to do two main things. So we had to bypass an alarm and do some SCADA hacking. And then we have the real intrusion phase in which we enter in the building, and then we have to reach our goals once we are inside. So in this specific case, we identified 3 possible scenarios. The first one was entering and stealing the PLC from the machine. The second one was entering and download the PLC data, so the software that is our goal, directly from the machine without removing the PLC from the machine itself. And finally, the third scenario was entering, placing sort of backdoor in the company network and access later the network and try to see if we can reach the PLC and so the data that is our goal. So after the first phases, so after the OSINT phases, after the on-site surveillance, we decide to go with the scenario number 2. But before going into details about the attack scenario, let's see quickly about the equipment that we use for the first phases. So this is what we use usually for on-site surveillance. So it's quite simple, mainly a camera with a good telescopic lens in order to see inside the company. Usually use some SDR in order to understand if there is some type of wireless alarms or stuff like this in place inside the industry in this case. And then we sometimes use a drone for air surveillance if we have a big, like a campus or something that we cannot see through from outside. And then we also need a lot of time and patience because you have to spend hours and hours just making picture and surveying the place. So a lot of time, a lot of patience is required. So in this case, we spent 36 hours, more or less, in doing this type of analysis, and the results were a good planimetry of the place. So the image is not very clear, unfortunately, because of the big screen, but let me try to point the interesting thing. So here and here we have some sort of workbench in which the machine were actually assembled and the PLC were mounted on the machine, because the machine were, like the PCs were bought from China, they assemble it in Italy, and then they mount the PLC and program it with their own software. In this area, we have some test bench in which the machine assembled were tested against some sort of specification from Lowe's or some entity, I don't know. And then we have in this other place a sort of storage in which I think assembled machines were ready for shipping were stored. We also have a small office here. I don't know what they use it for. And then we have another room that we don't know nothing about because there is no windows, so we couldn't see anything from the outside. And then we have the entrance. This is this corridor here with a couple of doors. And here and there we have some stuff laying around. We really don't know much about that. So this is what we found from the outside. As I said, we use the camera to take picture of the inside, and we have this quite clear picture of what we are going to expect from the intrusion. So we also found that the factory has an alarm system and the control panel is placed in the entrance. So the entrance is here, the control panel was right here. So we could take a good picture of the control panel from the outside because of the windows right in the opposite side. So unluckily, the PIN code to disable the alarm was not possible to be solved from the outside because the people were right in front of the control panel when they were inputting the PIN. So this is something that we could not do. As you can see, this is one of the pictures that we took from the outside. You can see that actually the alarm is off because it's work time. And so we had to find another way to bypass the alarm. So during the surveillance, we also mapped all the infrared sensors that we could see inside the factory. And after that, we decide to buy the same alarm model in order to find some vulnerability in the firmware or in the communication between the control panel and the sensor. We also found that, I forgot to mention in the slide, that the sensor were communicating with the control panel wirelessly. So there can be multiple vulnerability, as you already know, and so we decide to buy the same model and see if we can find something. So I don't know if you can see, this is a picture with the, no, it's too small, sorry. This is a picture with the map of the sensor. So there are one here, one on the opposite side, one in this angle, one in the other angle, and then there are 1, 2 in this room, one in the main office, and one in the entrance. This one has a limit around here, so after the control panel, of course. So when we bought the alarm system that they use, we found that they have an anti-jamming feature that has a little small bug that they allows a 15-second timeout before the alarm start the sound. So we can jam the communication between the sensor and the control system, the control panel, for 15 seconds before the alarm starts. Moreover, we also found out that the infrared sensor, the range of infrared sensor were not big enough to cover the entire area. So using this information and working in our lab, we found out that more or less this is the situation. Okay, so you can see the red circle is the range of the sensor that I showed you before. So as you can clearly see, there is like this corridor here that is not covered by the sensor. So our first idea was, okay, we can lockpick this window, enter inside, and we can do whatever we want. No, because this windows has no locks from the outside. The only lock is from the inside. So we could not unlock this window and get inside, and we cannot break it because, as I said before, we cannot do any disruptive method to get the goal. So the only way to get inside is through the main door. Luckily for us, the second door, this one, was usually left open because of convenience, I think. So what is the plan? The plan to get inside was to lockpick the first door, this one, get here, start jamming the sensor, run until the middle of the other room, because luckily the other door was open, and then if you can do that in less than 15 seconds, then we stop the jamming, the alarms start working again, and we are already there. We can work on the machine. And then we can jam it again to exit. Okay, that was the plan for the actual intrusion. But at this point, we have still to figure out how to get the data from the PLC. We decided that we don't want to steal the machine because the machine was actually pretty big. You probably cannot see the scale, but this side is like 25 meters or something like that. So the machine is around 2 meters per 2, so quite big to bring outside, and also it will trigger the sensor. It's quite impossible to do that in less than 15 seconds. So we decide to go with hacking the PLC in order to try to find a way to get the data. And as we did for the alarm, with both the same PLC that they were using. And we found out that there is a download and upload feature in the PLC that can be protected by a user-defined passcode. It's a passcode that the user have to provide to the software before downloading a receipt from the PLC, and that you usually have to also to input during the upload from the computer to the PLC. Of course, if you forget the password, you have to reset the memory of the PLC before you can reset the password. The passcode is only 4 digits code, so initially we thought, okay, we can brute force it. No, because after 5 failed attempts, we have a 30 minutes timeout lock on the PLC. That means that we can try in real time 0.16 passcode per minute. So it will require too much time. So we started analyzing the Modbus traffic between the PLC and the computer that communicate with it. And we found out that there is a sort of magic packet that the PC sends to the PLC to reset the failed attempt counter. So what we did is we create a new receipt by our own, we upload it to the PLC, and we start to analyze how the communication when we upload and download a receipt with the PLC works. And of course, with a known passcode, because we set the passcode in this case. So what we found out is that we have this magic packet that allows us to reset the counter. So we could actually reset the counter before the timeout goes in place. Moreover, we also found out that the passcode verification is done client side. So it's the PC that communicates with the PLC, is the actual that control that the passcode that you have inputted in the PLC is actually the same one that is stored in the PLC. So that means that somehow the PC have to read, the software on the PC have to read the passcode from the PLC. So there is a way for the PC to read the passcode from the memory of the PLC. And after further investigation, we found out that we can send custom commands, custom Modbus commands to the PLC in order to read and write arbitrary address on the memory. So that explains also this magic packet that I mentioned before that could allow us to reset the counter to 0. It's just an address in the memory that take care of how many failed attempts you have made to the input of the passcode. We can just reset it, or we can easily read the memory address in which the passcode is stored and then use the same passcode to download the PLC. Actually, the PLC software. Actually, since we have this command, we don't really need the passcode. We can just read the PLC memory and extract the software that we are looking for. The only thing is that we need to properly map the memory where the software is mapping the memory. That was the main thing, the main problem that we thought when we found out this thing, because we had also a very straight time constraint for the engagement. So a quick details, technical details about this packet. So maybe some of you already know what is Modbus ASCII. It's a version of Modbus that use only ASCII chars during the communication. So it makes easy for debugging purposes and for us to read the communication. So the packet in our case is slightly modified Modbus ASCII protocol. We have the same starting char, the semicolon, then we have the device address because we can have multiple PLC on the same device or on the same bus. Then we have the Modbus command, in this case 03. Then we have the payload for this Modbus command, a checksum, and the ending char. So in our case, the command is 03, as I said, and 03 in the Modbus protocol means read a holding register. This Modbus command usually has 4 bytes payload. In our case, this is slightly modified. It's a 5-byte payload, and it's not reading a holding register. It's reading an address in the memory. So the first 4 bytes is the memory address that we want to read, and then we pass as 5th byte of the payload the number of bytes that we want to read. So in this case, we can read from this offset 440 bytes. And the PLC will return us the data. Actually, I think I didn't modify. This is the address for the password. So, yeah, it's supposed to be a feature for the software that use these kind of commands to get debug information from the PLC, and in our case, also the password for the on-site, for the local verification of the PIN code. That's not it. I mean, okay, we can retrieve the password, but another interesting thing is that the password is stored in clear text. So not only we can retrieve it, but we can also actually read it immediately because there is no encryption. There is only a small encoding I will show you later. So to recap, at this point, what we have is we can read the data from the memory, from the device address. We can write on the device address, so we can change the PIN code to like provide a sort of denial of service attacks against a normal user that doesn't know about this functionality. And as I said, the passcode is only encoded, so it's not encrypted. The encoding mechanism is something weird, is this one. So for any X char, they have a correspondent X value, and sometimes it's the ASCII value of the char, sometimes it's not. I don't know why, but multiple tests show that this encoding table is the correct one. So to summarize, now we have a way to enter in the building. We have a way to download the receipt that is our goal, and we have a way to get out. So we put everything together, we create a small exploit for this. As I said before, this is the flow of the exploit. As I said before, we could bypass this first part, because actually we don't need the passcode to download the receipt, we could just read the memory. But as I said, the time constraint didn't allow us to map the receipt in the memory. So we didn't know exactly where the receipt was in the memory, and if this receipt was encoded in some way. So for respecting the timeline, we use the same software that the vendor provides, with just the pin code that we can retrieve using our exploit. So we use the exploit, we retrieve the passcode, we try to decode it, we pass this passcode to the software will download the receipt. So after that, we do the intrusion, we succeed. Yeah. Okay, so I like this picture. Question? Non-technical question. Yeah.
It was clear for me. How did you get in?
Okay.
How did you get out? You
way.
did the same way, like you jammed the signal.
You jump after we get the PLC software. We jump the same way, and we use the same way to get through the same path of before. So we use the open door, and we reach the second door, which is we left open because we already lockpicked it, and then we get out. And
when you send the commands for the password, right? Mm-hmm. How did you do that? Through they has a keyboard, the PLC, or you connected some cable?
What we did is we used a Raspberry Pi with all the software inside. We connect the Raspberry Pi through Ethernet to the PLC. The PLC has an Ethernet port, I forgot to mention. So the Raspberry Pi will automatically, there is a Python script inside that will automatically, on the power up, will automatically send the correct byte, the correct packet to the PLC, retrieve the passcode, launch the software, and save on the memory the software of the PLC. You're welcome.
Hi, nice talk.
Thank you.
What about the timing? Did you during the night, weekends? Like there was a special moment where you get in and out?
Yeah. So for
the people in the room, I don't know if they were workers. No.
So what we usually do in the surveillance part for most of our engagement is to try to understand the behavior during normal workday and also during the weekend. So the 36 hours that I spoke you before were not like continuously. We spend like 12 hours during a normal Monday, and then like 24 hours during the weekend. So we have a clear idea if there is like external surveillance, so if there is external companies that provide surveillance, and at what time the people usually come to see if everything is okay and this stuff. So what we did at the end of the day is in the intrusion part, the actual intrusion was done on the weekend during daylight, because there is no surveillance during daylight. We could get in quite easily because the logs were shitty logs, and then after that we act normally, and all the intrusion part is done in like 5 minutes, because the software will download the receipt in 30 seconds. The only thing was jam it, be sure that the sensor were jammed. After we got sure that it did work, we jam it again and then get in.
And question, how did you get the model of the PLC? Did you get it with a camera from the outside?
Yes.
Oh, okay.
Because
far away, right?
Let me get back to the map. Okay, so if you see, this is our targets. So we targeted this device that was on this test bench. You can see that from this window and from this window you have a clear see of the machines. And from these windows you can also see the PLC inside. And since we got quite good lens for this kind of work, we could identify the brand and also the model of the PLC, because it was printed on the main case of the PLC itself. So yeah, this is all part of the first two phases. So the OSINT, remote information analysis, and the on-site surveillance. Questions? Yeah.
And did you give also some security recommendations at the end, like how to improve it, or it was not part of the job?
In this case, the recommendation that we gave them was to change the PLC. And we didn't do yet the full disclosure to the PLC manufacturer because of this NDA. So we need to wait until the NDA expired to communicate the vulnerabilities to the vendor, and they will probably won't fix it because it's, as I said, from the meme, they consider it a feature because the software they ship use this feature to do debugging, to get debugging information, to get the passcode, and this. They also had to rewrite the whole software. So, in my opinion, and from my experience, they probably won't fix it, but we'll do the communication some months later.
Part, like the sensors, mobility, like did you recommend something about the doors?
Oh, yes.
About the...
Yes. In this case, what we recommend is another alarm system that had, first of all, a fewer timeout for the jamming feature, and moreover, it also has some of the sensors were cabled and some of the sensors were wireless, so there is a bit of redundancy. And we also recommend to install sensor on the windows because we didn't break the windows, but the windows had no sensor and no alarm sensor on it. So a real attacker can easily break the window, enter inside the building, and do the same thing. Moreover, the new sensor were also placed on the ceiling instead of on the walls, so they could cover the whole area more easily. The range was bigger, of course, and this kind of stuff. Yeah.
Okay, so
non-technical question.
Yes.
The facility didn't have any CCTV cameras, or
Sorry, can you repeat?
the facility didn't have any CCTV cameras for monitoring?
On the matter?
Yeah.
Oh, yes, yes. They actually use our recommendation for. Yeah, they implement our recommendation in the following weeks. They still haven't replaced all the PLC because of production issues. That you have to buy it, you have to test it, you have to modify some part of the code because it's a different PLC, blah, blah, blah. But they are taking care of it, yeah, strangely. Okay?
okay, so thank you, Matteo.
Thank
So
you.
if you have any further questions, you can talk to Matteo anytime.